So this is more typical of an actual exam question where we haven't got 1 as our complex number, and instead we've got something like 2 plus 2i, for example. Now, these aren't too much more complicated, but you still need to know how to do these. So first we're going to write it in Euler form. So to do that, we need the modulus of this number and its argument, and those are going to be equal to the modulus cubed and the argument times 3. So the modulus of this number, so modulus z cubed is equal to the square root of 2 squared plus 2 squared, which is equal to root 8, or 2 root 2. Now the argument, so if we plot this on an Argand diagram, so we have 2 this way and 2 that way. So this is just going to be a 45-degree angle, or pi over 4 in radians. So arg z cubed is equal to pi over 4. Now what we do is write it in Euler form. So z cubed is equal to 2 root 2 e to the I times pi over 4 plus 2n pi. Again, we add 2n pi so that we can expand out this number and get 3 roots instead of just 1. Now what we need to do is cube root both sides. So this is going to be cube rooted and this is going to be divided by 3. So z is equal to root 2 e to the I times pi over 12 plus 2n pi over 3. Now again, we have a cube root, so we only need 3 numbers around 0. So we're going to choose n is equal to -1, 0, and 1. Now you might think that because there's a pi over 12 here, we might actually have extra numbers that we can choose for n and get more roots, but you'll see why we actually don't in a second once I go through it. So we'll choose n is equal to -1 first, z is equal to root 2 e to the I times pi over 12 minus 2 pi over 3. So let's quickly calculate pi over 12 minus 2 pi over 3. So that's equal to minus 8 pi over 12. So that's going to be equal to minus 7i pi over 12. So minus 7i pi over 12. For n equals 0, this becomes 0, so we just get root 2. So z equals root 2 e to the I pi over 12. And then for n equals 1, so we get pi over 12 plus 2 pi over 3, which is equal to pi over 12 plus 8 pi over 12, which is 9 pi over 12. 9 pi over 12 is equal to 3 pi over 4. So our number is going to be z is equal to root 2 e to the 3i pi over 4. So these are our 3 numbers that we evaluated from n equals -1, 0, and 1. Now let's try n is equal to 2. So n equals 2. So z is equal to root 2 times e, and now we're going to have pi over 12 plus 4 pi over 3, which is equal to pi over 12 plus 16 pi over 12. That's going to be equal to 17 pi over 12. Okay? Now, let's just write that for argument's sake. So 17i pi over 12. Now, let's plot all of our 3 numbers from before and then this number as well. So z is equal to, let's plot this one first, so I pi over 12. So that is going to be somewhere over here, like this. Then z is equal to root 2e to the minus 7i pi over 12. So that is going to be somewhere over here. And then z equals root 2e to 3i pi over 4. So that is 135 degrees, so it's going to be over here. And all of these have a length of root 2. Now, let's choose 17 pi over 12. So 17 pi over 12 is equal to 6 pi over 12, which is 90 degrees, plus another 90 degrees, 6 pi over 12, plus 5 pi over 12. Okay, so we'll go here, that's 90 degrees, another 90 degrees, and then 5 pi over 12. That's actually going to end up here, because this angle from here to here is equal to this angle here taken away from 180, or just pi. So this angle here is equal to pi, and then we minus this angle here we'll call theta. So this angle here, well, that was the argument of our negative n. So that was 7I pi over 12. So this angle here is equal to 7 pi over 12. And then this, and that's equal to pi minus theta. So pi minus theta equals 7 pi over 12, which means that theta equals pi minus 7 pi over 12, which is equal to 5 pi over 12. Now, if we have a look, this angle here was equal to 5 pi over 12 because we went half 90 degrees, and then we went 5 pi over 12, as I showed over here. Now, this tells us that this angle has the exact same argument as this number here. So the number we got from n equals minus 1 has the same argument as n equals 2. That shows us that we don't actually have to go any further than 1, and we don't have to go any further backwards than minus 1 for our choices of n. And you'd get a similar result if you chose n equals minus 2. You'd get the same argument as n equals 1. So this tells us that these are all the roots that we can possibly get.